Hello everyone. Welcome to this video. We're going to look at all things Rust. Learning Rust is the name of the channel, and that is what I'm still doing. So I've done quite a few projects recently and tried to actually learn some decent stuff. I've been learning about Mutex and RwLocks. I've put all these articles on my website. If you want to come and look at them, they're on redandgreen.co.uk. So yeah, this video will basically be me talking about the things which I've been doing recently. So this, the other thing I've been doing is you had to look at lazy static. It was one of the things in the Rust in a Month of Lunches book. I think it was about chapter 19, so it's quite late on. But yeah, I got the idea I got the concept of static versus const, but lazy static is just a bit nuanced to it, really. Rust benchmark. So been using the Criterion crate as well, just dipping my toes in the water with that. There's a lot to it, and yeah, I just wanted to become aware of it and just familiarize myself with it for use on future projects. The other thing which I've been working on quite a bit is minifb. So I left a community post on my channel and I was asking if anybody was interested, or I did the poll where people were interested in a project involving iced and surreal. I will come back to that. The ice documentation, I'm not good enough to be a pioneer on creating the videos on iced version 13 or 0.13. And some of the projects I've been doing recently, I have asked ChatGPT for help. Typically what I'll do, if I explain what I've been doing, so I ask it for kind of I double check if it thinks something's a good idea. I get it to do me an example. I run the example, and then basically I then pick it apart, strip it down, and then I typically go onto the Rust book or get one of my own books and read up on the topic in question. So this one I've just clicked on here is I was using minifb. So minifb is a Rust crate for doing frame buffers. I'll show you the game that I've built in a minute. I'll do that at the end because that's good for retention on YouTube videos, so I gather. A lot of what I've been doing has been refreshing myself on using a 1D array representation for something which is actually has two dimensions. My good friend Code Monkey King, he introduced me to this a few years ago when I asked him for help on a kind of a 2D board game idea I had, and he's written a lot of chess games, and I think a lot of games in general use 1D array because it's faster. Um, I'm not sure if there's a significant, but I think it's kind of best practice. If anybody can comment on that, I'd be interested. So 1D array, I don't know if I've not documented the one that I really want to show you. So let's just go over and that's another project I've been tinkering with, which is using Rust to do the embeddings using fast embed and the basic all mini LLM, all mini LML 6v2 model. Anyway, I digress. So if we go up to my repos, I'll talk about WASM in a minute. I've been doing some WASM as well. This is kind of one of my bigger projects. And the other thing I want to talk about, there's so many things to talk about because I haven't done a video for a while. But one of the things it's probably obvious to many of you, especially if you work in sort of corporate environment, but is cross compiling. I did a video on cross compile quite a long time ago, about 2 years, almost 2 years ago, when I first started doing these videos. But obviously, that type of machine, it can be slow. So as you can see here, Rust cross compile for Raspberry Pi. Do your cross compiling on GitHub. So my good friend Code Monkey King, he's got a Raspberry Pi, which he does a lot of stuff on. So what I did was I created a workflow, cross compile Pi 5 YAML, and you use the the checkout actions as normal, the tool chain and so on, and then just down here you specify a different target, and you have to run cross build, which is a Rust crate. Anyway, it's here if you want to look at it. You can feel free to copy it. If you copy it and just modify it with your project name, it should work. So here's one of my projects I've been working on recently, and it's using minifb, which is the frame buffer crate. And what I've been doing is converting PNG background images to bytes. The frames update, so I've been experimenting using constants and frame FPS, different FPS rates, and it's taught me quite a good bit about using references rather than cloning. The code was really slow, and what I was actually doing was inside the main game loop, I was cloning the background image inside the main game loop, which was not good. In the end, what I did was I had an enum, and this screen changes. You see the little mouse there. So I've got several images, and as the score, let me demonstrate the game. So what I'm going to do is I'll install it. I think I've deleted it. So let's just go and install it, and then you'll see what I'm on about. As I said, this video really is just me talking about stuff I've done. So still learning Rust, obviously, but this probably won't get many views, because how do you give a title to a video that really should just be called stuff I've been doing? It's not really going to be that good for any keywords, is it? So let's go into myth cargo. Let me run it. It's not that many crates. minifb and image. So image helps convert the PNG, or it actually automatically detects whether it's a JPEG, PNG, etc. And it knows how to unpick it and convert it into bytes. When this runs, I'm playing it on quite an old laptop, but it seems to handle it fine. And I think even on Raspberry Pi 5, with my recent improvements to it, it runs fine. It was using up nearly all the CPU at one point, but that was because I was doing the clone. So minifb allows you to detect keystrokes, and you might think, well, make building a game's a bit pointless and a bit of a waste of time and not very constructive. But part of my thought process on this was I've also added collision detection. So when the red cursor picks, you have to stop the snow drop. The snow landing on the cat is basically the premise of the game. And you see up here we've got score, top left. And when it goes into minus, as more and more, if you miss some of the snow, the score keeps going more and more minus. And as it goes more and more minus, you see one mouse, two mouse. Eventually, the screen goes grey. You're nearly dead. But the point of this was to actually become more proficient at using Rust, obviously, and also to look at how you can use minifb to work with the screen, basically. So this is quite a bit more low level than iced, obviously. So, but it doesn't have the operating system drop downs and sliders and the widgets. But if you've got a project where, for instance, say this was a home automation, you wanted to do a home automation project, and then you wanted an image of, for instance, say you wanted an image of your underfloor heating, or you wanted an image of a plan view of your house. Where this image I've got here is just of obviously an AI picture of a cat. You could have an image of the plan view of your house, and then you could move using the cursors. I'm just using the cursor keys here, and I'll show you the code in a minute, but you just detect the cursor keys. This is not as easy as it should be, but um, let me start again and I'll show you what happens when you win the game. I made too many mistakes there. So I've used random here as well. Used random to generate the snowdrops, the snowflakes, whatever you want to call them. Um, so there's an enum which basically stores the background, and I've got about 5 different backgrounds. I've got the one with the one mouse, two mouse. I've got the grey background. This is the main background, and then there's a winning background, which in a minute, hopefully, you'll see. Um, so with with minifb, it's I think it's described as being more for prototyping. You see, I put some code in to make the cursor bigger. There's a little kind of power up once you get to 10, I think it was. So I'm just using the cursor keys. If I wanted to escape the game, because the game is running in a separate thread, sorry, the main loop is running a thread. At the very start of that game loop, I'm also checking for the escape key, and there we go. So 1. If I press the escape key now, it works, which is good because sometimes you might write a game or you have a loop running and it's too busy. So that again, you just need to think about how you're going to use the threads. Um, I'll show you cargo toml. Zoom in. So I've used image, minifb, rand, and oh yeah, rusttype. So that was interesting as well. So to try and print text to the screen when you are using a buffer of bytes, I started looking at glyphs, and there was a ab_glyph crate, but I found that rusttype was really easy and it just did what I wanted and it looked nice. So the one thing I had to do was just download a font. There's cross term there, which is just a dev dependency. So it's the first time I've used dev dependencies, but it's you just add it in cargo toml, and obviously it only affects stuff that you're doing in the background. If I was just compiling this on my local machine, then this wouldn't be needed. But obviously the GitHub Actions, the YAML workflow picks that up. Trying to optimize it as much as possible. Because I was sending it to my good friend CodeMonkey King, who's on a Raspberry Pi. So let's look at the code. I'll tell you what, just as I don't normally use VS Code for very much anymore, but let's just look at it in VS Code. Sometimes it's good for just because you can collapse the functions a bit more easily. Right, so we've got crates that I just talked about, image utils. These are 3 functions, or sorry, not 3 functions. It's 1, 2, 3, 4, 5, about 8 functions that I made, and then I just used mod to bring them in. Constants. I think with games it's quite common to use constants for kind of the game settings. Potentially, I guess you could load those from a config file, but for a small game, I think this is typically how you'd do it. We've got drop size. That's the size of the snowdrop. The number of drops falling from the ceiling. It's all self-explanatory. Just looking there, you see the I32. Just be aware that sometimes if you're doing iteration, you will be using usize, and if you mix up your usize and a standard I32, you can get an error. So I think even in here I had to use as I32 or as usize just to do the type conversion. So I just got a struct for a raindrop, and then we're straight into the main game loop. So these are the backgrounds, which I've put those into an enum. So winner image, mouse 2 image, mouse 1 image, image data. They all go into an enum, and then depending on what the score is, as the score changes, the background changes. So that's how when the score drops. So if some snow lands on the cat, the score drops below a certain level, and then you get the mouse 2, so it's 2 mice. And obviously, really, I should have the 3rd mouse for kind of game over. But I've kind of left this open-ended because I might come back to it and I might add some more levels. but for now I'm really happy with it and it works. And so my good friend CodeMonkey King's tested it on the Raspberry Pi and he says it's really responsive. So yeah, this is standard. This is kind of the mini FB syntax. So you create a new window. Height is and width is usize. Window options are default. Um, and then there's lots of stuff. So for instance, that's obviously the cursor size, and the cursor size changes when the score gets to 10. So that was just a little bit of extra stuff I had to add in. The raindrops. So we use um, random, and yeah, I've just added drop delay. I as F32. See that because I otherwise would be a U size. So this has been good practice at using map and collect and kind of more functional style. Quite often it's so there's the main game loop. We just say if you want to quit, then press escape. The frame start. I think I added in the time. I added these in for when I was checking the timing. I think what was I checking the time? Start time elapsed. 2 weeks ago, and already I've forgotten why I included start time. Apologies for that. So cursor movement. This is mini FB detecting what keys you're pressing. So up, down, left, right, and those are the cursor keys on your keyboard. The cat rect. So this is for the collision detection. So basically, I've created a invisible rectangle. Yeah, in an ideal world, I guess with like a professional game programmer, there's probably some way how you can actually do sort of edge detection on the cat. So really, this is a bit of a cheat. So even if the snowflake lands above the cat, it still actually is a collision really because we're just using a rectangle. Draw square. So the square, that's the actual red thing that we move about. So it's the cursor X, the cursor Y, it's square size. Buffer, so we're using buffer many places. It's been a good practice at using buffer. Yeah, it's a lot of code. Well, it's quite a lot. It's one of the longer bits of code that I've done for a while. So this is just the main, and probably I should refactor it. I don't know. Maybe not. If I show you the Explorer folder, please. I'll just show you. So we've got main, which I just showed you, and I've got image utils, which is what I also wrote. And you can see there, that's where I'm including the font. One other interesting thing is I used include bytes macro. So it makes your binary bigger, but what it means is everything can exist just in one binary executable. You don't need assets and you don't need kind of installer and you don't need paths to different folders or whatever. Everything is inside the binary. The binary is I think it's about 6 or 7 megabytes when it's compiled. So draw square, draw raindrop. So these are all the kind of the image things. This is a collision detection. I used ChatGPT here, I'm not going to lie. So yeah, it's basically the rectangle 1 and the rectangle 2. Rectangle 1 is kind of one of them is the snowflake and the other one is the cat. I mean, this is just the function, but in the actual usage, one line is the cat and one line is the snowflake. The get background for score, so that's the mono background, that's grey background, 1 mouse, 2 mouse, the original, and then the winner background. I've used those. I've given those lifetimes. This is the first time I've really used lifetimes. I think it was necessary to use those because otherwise I would have been doing clones. I may or may not have used those unnecessarily. I would come back to that one day once I'm a bit more experienced at using lifetimes. My default sort of modus operandus is not to use lifetimes, so when I do come across them, I'm kind of yeah, a bit naive. So this is the good bit. It's loading the background. So you've got the image data, which is actually an array of U8s, and then it returns the buffer, which is a vec of U32s. And I've even put in some tests down here. Again, I asked ChatGPT for some help with these. So I think what's surprising with tests is you almost end up rewriting an entire function. It's not trivial. So you almost having the same. You can see where I am now on the minimap thing. So yeah, the tests are almost as much code as the actual functions. But that's how it is, isn't it? And to be honest, I wrote a lot of the code first and then wrote the tests after, which is yeah. The the U8s get put into a U32, so you've got 4 U8s here, and you're doing the bitwise left shift with the most significant bit going is A and then B. So A, then R, then G, then B. A is the alpha, if you don't know. So on an image, you can either have RGB or you can have RGB with A at the front, and that's the alpha. That's basically the transparency. So you've got transparency, then the red value, then the green value, then the blue value. It's getting returned as a buffer, which is vec of U32. It's a vec of those. So going back to what I started showing you at the start was actually the array representation. In this article here, which I did, which I called Understanding 1D Arrays for 2D Pixel Storage and Graphics. I'll let you read this. I won't bore you with it, but there it is. You see the alpha. So you've got FF. So that's 255. Yeah, 255 there. Yeah. If you're familiar with routing and switching, you'll know that FF crops up when you've got is it MAC address flooding? Basically, that's just that will just send to everyone on your subnet if you just fill it with Fs. You probably should know this. So when you are using a 1D array to represent a 2D coordinate system, you multiply the row times the width, and then you add the current column. And this is universal. You really should know this if you're going to do anything ever with 2D with arrays, really. Yeah. I came across some other functions, flatten as well, and there's one called flat map and there's one called flatten. If you just want some smaller code to mess about with, I just did this code where you can just create a window and experiment with rusttype and minifb. So that's only 77 lines. And that's quite a nice font. That's you can supply your own fonts. That's Fira Code Bold TTF. So there we go. That's the minifb project. While we're here, I'll just hopefully I'm not boring you. If I put the time, I'll try and remember to put timestamps in it, and then you can skip to good bits if you're not interested in the game or minifb. Let's go to another project I want to show you is my WASM project, which I'll show you I'll show you that at the end maybe because not everybody's going to be interested in games. I've just wrote a small log buffer pixelating images, so more image stuff. That's quite a small, simple one. What was I going to show? RwLock. This is quite a good one. So there's some this is actually doing a bit of work, and I've put it on GitHub pages, so we'll run it here. So it's legacy Bitcoin address generator. The new BCH32, BEC32 ones are a little bit more code, so I thought this was just easier to get started with. So you paste in the public key. So you get when you generate a key pair using elliptic key cryptography. So you generate a key pair. The secret key secret private key you don't ever give to anyone. Public key you can use, and you use that in your transactions. And from your public key, you can generate a Bitcoin address. There we go. That's all done using WASM and Rust. There's the address. And if you go to inspect, you can come and look at this. If you come on my GitHub, you can actually come to this GitHub pages thing. We'll go to network. Let's run it again. If you see that, you can see down here, Bitcoin hashing WASM bg.wasm. And that's the WASM code, which is 44 KB. And it's actually done quite a lot of work. It's done some little bit of cryptography stuff. If we go into source, I'll show you what we've got. This is just a lib. So with WASM, you just do a lib.rs. You've got SHA-2, RIPE-MD. So those are the two flavors of hash that you use to generate a Bitcoin address, or the old style, well, all Bitcoin address. WASM, BindGen, Prelude, that's important. Everything from BindGen, Prelude. So there you've got new, update, finalize. That's fairly standard with hashing. You create a new hash share, then you update it with some input, and then you finalize it. So that's SHA-256, and you've got RIPE-MD 160. If you're not interested in Bitcoin, don't worry, but this is still relevant to learning Rust. Using hex decode, extend there, so extend from slice encode. Okay, so that's just three. Is it three or four? Three functions which go into lib.rs, and then you can compile it to WASM. Once you've compiled it to WASM, then you can create your web page. So I've just done index.html, index.js. Don't need to worry about React or frameworks or anything. You can just do, you just call the script command down here somewhere. Yeah, so right. On click, generate new Bitcoin address. So that is generate new Bitcoin address is the function in here. Window generate Bitcoin address. I don't know enough about the DOM and all that kind of JavaScripty stuff, but this works. One thing you might need to, one sort of gotcha is when you run it locally and test your WASM locally from your Rust project, and you've built or you've asked ChatGPT to ask you to build you a little JavaScript and HTML bits and pieces, that needs to be ..// typically, if you're doing a web directory at the same level as src, your source folder. One other thing I had was when I was pushing to GitHub so that I could automatically push, and then the pages would automatically pick up the workflow. Git on my Linux machine was ignoring, or my git ignore file was missing pkg package. Without that, you're missing this one and that one, and that's the actual, that'll be view. That's just, you won't be able to view that, or you try to, it'll just be illegible. But that's that's just two gotchas there. One is get the path right. Get the path right in your index.js. You may need to put in the ../. So that's one gotcha, and then the other gotcha is the git -f, I think, is the switch. When you're doing the git push, you just need to force it to include the pkg directory, which gets created when you do your WASM stuff. So yeah, if you want to try it, just come here. You could copy this project and just, if you didn't want to do Bitcoin key address generator, you could simply modify these three functions and do something else instead. So what I'll show you as well, just in case you're not interested in that particular project, let me show you. I'll just quickly show you another one, and then I'll round things up. So yeah, I was looking at message queue yesterday. That's yeah, it's a bit of a rabbit hole. Yeah, I ran into this. I got this working, but I ran into a few issues with Arc and Mutex and stuff, which I'll come back to in a second. What else did I do? I did this one. Yeah. So if you live in the UK, you'll know that we're about to be hit with an extra £2.5 grand on our stamp duty when we buy and sell houses soon. But yeah, this is just another. This is all done in WASM as well. So if you're buying a house for £300,000, up until next March, you'll have to pay the government £2,500 in tax. So there we go. But this don't use this because this will be out of date soon because the government have put the tax up. But again, this is just a WASM project. The WASM is doing all of the calculations. This actually gives you the instructions on. This is based on an original video or project I found by Beck Brace, who's also on YouTube, does some Rust videos. So yeah, basically you start a new project, you add WASM bindgen, you have to add that into your cargo toml. You go into lib.rs and then you create your functions. If your function's called XYZ, and then you bindgen prelude, you always use that. Then you do your build, WASM pack with the hyphen, space build, -- target, web. You don't have to use that, but if you do, then it creates some handy stuff, your package directory and so on. I don't know enough to talk knowledgeably about that, so I'll move swiftly on. But yeah, target web I think is quite a good way to, if you do that to start with, and then you can consider leaving that. Or there's other targets you can do as well apart from web. But setting up the web environment, create an index file, and then you just reference your. Again, there's no point in me boring you with how to do it really. It's all here, and you'll probably want to come in here. And here I had my index HTML actually in the top level. Yeah, and actually there's the script. So if you don't even want to make a separate JavaScript file, you can just put the actual JavaScript code into your index HTML, and it's all there. It's all in one place. And then you have to do the import. You notice how the path's different there. There's not the ... and that's because where the index is at the top level, and yeah. So it's awaiting it. JavaScript knows that it's async. You're telling it it's an async function. We're saying run it. And then you do all your JavaScript-y, get element, and so on. But that income, that is you see that comes from what the label is, and that's what the user puts in. So we're actually collecting some user input, as we were with the Bitcoin one. So right, that's there. WASM-SDLT if you want to have a look at it. If you'd like, I can do a video on this. I think because I'm not very advanced, I think I could probably do quite a nice sort of beginner-friendly video on doing WASM project that takes user input for Rust. If you would like that, let me know. Else, let's move swiftly on. And I'll just show you what was going. The maze game. What else is different? That's actually using. I'll just show you the source code for that. So that's what it is. And that maze is actually a 1D array. So if you've done snake games or stuff, you'll probably think, "Oh, this is obvious," but yes, it's just a vec. So it's a yes. Array and vec sometimes get used interchangeably, but yeah, this is a vec. And you can see that these noughts show the white bit and the one is the black bit. Arrow keys to move again because I'm using minifb. So what you've got is you've got the color, so in the squares, so you've got the grid and then you've got the pixels. So you've got inside your grid, you've got a pixel, and then inside the pixel, you need to color the pixel in with the correct color. So handle input is walkable is basically another sort of type of collision detection, and it's basically saying if it's walkable if the cell has got a 0 in. So that line there, 113, pretty much is the key to all of this entire code. So you can walk if there's a 0. Again, I don't. I apologize, I can't explain this particularly well. It's probably quite advanced for me, so I've got it working, but I can't explain it very well. That's what I'm trying to say. Or I could do, but I'd probably take 3 hours to prepare, and I haven't got 3 hours to prepare to tell you how to make a maze video. Right, next, let's have a look at one last thing which I was going to cover, which was we just have a quick look at Criterion, and what it does is it benchmarks your functions once you've changed them. So it's more for unit tests rather than integration tests. There's a book, which is there, cargo book, cargo bench, and benchmarking Rust code. This is a very good article on deptagency.com. You're better off just going straight here from my GitHub page, really. You create a benchmark file. It's got it's something called a black box, a criterion group, criterion main. You need to inline these, and yeah, see, it's like making a test. You do it with librs, and yeah, then when you run the test at the end, there's a macro main which runs all the benches. You need to make a directory called benches, and I just made something called benchmark.rs. But and then you get a HTML file with all these graphs in. So when you run it, you get this, and then obviously the second time you run it, I don't know if you see it here. No, you won't. Let's go on my article, which will show it to you. The second time you run it, you get like a red graph and a blue graph, and you can see here. I added some more code in, which actually slowed the function down. So the second time I ran Criterion, tell a lie. Red is the previous version. So the previous version was fast and it ran in 20 nanoseconds. I added some extra stuff and then it slowed it down. And the blue is the more recent one, which then took significantly longer. So you create a directory called benches, and then you need to have a file, a .rs file, which you then call when you run it. I called mine range benchmark.rs. So I pretty much got going with the DEPT tutorial and then just gradually modified more and more stuff to make it my own. So those are you see these extra lines you need to add to cargo.toml. So you need to add bench with 2 square brackets. name equals range benchmark. That's the name of your .rs file, which is that file. Yeah, and then when you run it, you create your functions, you create your bench. So that's your libs. That's just your normal code. As if forget all about Criterion. Then you add your benches directory right at the end, and then you add your range benchmark.rs with this in it, which has got the macro. And then when you run it, you've got report. So and to call it, you just do cargo. You do cargo bench, and you can see there it does. I don't know. It's about 3 million tests or something. So it takes a minute or so. Yeah. So you probably want to do this kind of when you want to start optimizing your code, not when you're first starting out. But yeah, it's handy to know and be aware of, and I think it's something to probably keep coming back to and just keep in your hand, keep practicing with. And you know, if you're not writing anything that's if you're just doing a little hobby project, you may not need to do this, but it's good to know. You might get asked about it in an interview. Who knows? Then the one last thing was a mutex or an RwLock. So this was a question which I asked myself. I Googled it, and then I pretty much found the same question, which was on Stack Overflow. The TLDR, if there's lots of reads, use RwLock. So why even use RwLock at all? Well, use RwLock when you are trying to, you've got multiple threads trying to access one bit of data, and you don't want a data race. Or so if you know what a mutex is, you will understand what an RwLock is and does. So choosing between a mutex and RwLock in Rust depends on the nature of access patterns. So it's basically a design choice. So use the mutex when only one thread needs to access the data at a time. And then with RwLock. So I remember, again, this channel is called Learning Rust, and I just want to sort of share how I'm going to go about remembering this. So using RwLock, the R in RW, I'm going to associate that with read, and that's how I'm going to remember it. RW, read, write, lock. So read. If you want to read more frequently, then use RwLock. It's often more performant because multiple readers can access data simultaneously. That's the key there. So with a mutex, you would only be able to do one at a time, one read at a time. There's comparison there. So only one thread can lock at a time. Sorry, I said read. Only one thread can lock at a time. With RwLock, multiple readers. If most operations are reads, use RwLock. If data is frequently modified, use mutex. So the typical example you'll see is, I'll put them there, but the typical example you'll see is the standard textbook one where you're just incrementing a number. You know, if you've got 8 threads, you're just incrementing a number for each thread. So that's there. And yeah, you can read about lazy static and some other stuff there. There's no adverts on here, by the way. There's just some, you know, AI of attractive ladies and a few cats, but there's no adverts as such, other than if you do want some web hosting, you could try WebDoc. I use them. They host this site, and perfect. Been using them for about 3 years now, and just, yeah, faultless. Really easy to use, fast, just no nonsense, absolutely no nonsense. They've got the when you generate your own certs, forget what it's called. I forget, but you can generate your own SSL certs free of charge. You don't have to buy the SSL certificates when you buy a domain. Scrape ops, if you're into web scraping, you could use these people, and that'll give me a little a little bonus, and I think you get a 10% discount. So if you're into web scraping, do that. And yeah, red and green. Say this has been going. I've been adding to this now for several years. So yeah, and do the search if you want to just find anything you're in Python as well. Some AI, some web scraping, Python type stuff, Quadrant, vector databases, Flask, Rough, written in Rust. So a bit of a. I don't know why it's so controversial that Python people get really upset about a linter that's been written in Rust. Just use it. It's fast. Don't worry what it's been written with. Yeah, so you see, this goes back to March 2020, which I think we all know what happened to the world in March 2020, don't we? But there we go. Well, that's it for now. I'll be back in due course. I don't know when, but if you like these videos, or if you want me to make one on something you've seen today, then just give me a shout. Yeah, it might be a good idea if you want me to do a sort of a beginner-friendly WASM, how to build a WASM project in Rust and deploy to GitHub. That might be a good one. Let me know if you think that's a good idea. Otherwise, yeah, thanks for watching. Subscribe, thumbs up, like, comment, all the things for YouTube that what their greedy algorithm asks for. So yeah, thanks for watching, and yeah, have a nice day.